All right, strap in because today we're diving deep into how AI is learning to understand 3D scenes.
Yeah, really, see in 3D, which is way more complex than you might think.
And we've got this research paper on a model called Video 3D LLM.
A fascinating new approach.
So imagine a computer that doesn't just recognize, say, a chair in a photo,
Right, right.
but it gets where that chair is in the room, how far from the window, like could you even squeeze by it?
That level of spatial understanding is what we're talking about.
Okay, so this model, it's not working with the usual 3D data, right?
It's a really flipping the script.
Instead of like point clouds or whatever.
Exactly. Those static representations, they kind of force feed the AI a disassembled 3D puzzle.
Uh-huh, I see.
But this model uses videos.
Oh, that's interesting.
So much more natural, right? Like how we experience the world.
It's learning from the flow, like a movie.
Exactly, exactly.
Instead of trying to piece together a 3D world from like a bunch of dots.
And get this, they've added 3D position encoding too.
Okay, now you've got to explain that.
Think of it like each video frame having a hidden GPS map.
Hmm.
So the AI knows where everything is located in that 3D space.
So it's not just seeing the objects, it's understanding their location, like their relationship to each other.
Spatial awareness, you got it.
Wow.
But hold on, all that video data,
Yeah,
processing it could be a real resource hog.
I bet.
So to tackle that, they use maximum coverage sampling.
Okay, now you've really piqued my curiosity.
Well, imagine scanning a room. You don't need every angle.
Right, just enough to get the gist.
That's what Video 3D LLM does.
Mhm.
Picks the most informative frames from the video
Ah, so it's still understanding the scene.
without needing to process everything.
Efficient.
And they use a greedy algorithm for this.
A what?
Basically, it's choosing the frames that reveal the most new information at each step.
Clever.
So now we've got this AI that gets 3D,
Yeah.
but what can it do with that understanding?
The paper hinted at some pretty amazing stuff.
It's mind-boggling, really.
Because it's built on video, right?
Yeah. That foundation opens up all sorts of tasks.
Like what?
3D visual grounding, for example.
Okay.
You could say, find the blue ceramic mug on the shelf next to the window,
And it could actually pinpoint it.
based on your description. Yep.
No more searching for a needle in a haystack.
It's like a 3D search engine on steroids.
That's incredible.
But it goes even further. Think 3D dense captioning.
Meaning.
It can describe an object and its location in detail.
Like what? Give me an example.
Imagine it saying, there's a vintage floor lamp with a floral shade tucked behind the armchair in the corner.
Wow, painting a picture with words.
And then there's 3D question answering.
Okay.
Ask it, is the bookcase taller than the fireplace?
And it could actually figure that out.
By analyzing the scene, just like you or I would.
So we're talking spatial relationships, detailed descriptions, it's like.
A virtual tour guide who actually understands the space.
That's a great way to put it.
And here's the kicker, this model.
Yeah.
It's outperforming other models on those standard 3D understanding tests.
Really?
But what's even crazier, it's doing it with less 3D training data than some of the top models.
How is that even possible?
That's the beauty of using video data. It's efficient, intuitive, it's closer to how humans see the world.
So the video is key. It's not just the individual frames, it's how they flow together.
Exactly, that temporal information.
And of course, the 3D position encoding.
Giving it that spatial awareness.
This is a game changer, honestly.
Opening up so many possibilities for AI that can understand and interact with their surroundings like never before.
The implications are huge.
Absolutely. It's like we're entering a new era where 3D understanding is the norm for AI.
And thinking about applications, this made me think about people with visual impairments.
Interesting.
Imagine an AI assistant that could describe their surroundings in real time,
Wow, yeah.
helping them navigate not just avoiding obstacles, but understanding the layout, the relationships between objects.
Giving them real-time spatial information. Incredibly empowering.
And with wearable tech, this could become a reality soon.
The potential impact is just mind-boggling.
This has been a fascinating look at Video 3D LLM so far.
Yeah, we're just scratching the surface.
But there's so much more to explore.
Definitely. It really is incredible we're moving beyond AI that just recognizes objects in a flat image.
Yeah, now it's this 3D understanding.
A true game changer,
And we talked about how efficient this model is.
especially compared to some of those data-hungry giants out there.
But I'm wondering, what challenges did the researchers face to make it this efficient?
That's a great question. One hurdle was figuring out how to represent that 3D positional information accurately, but also, computationally manageable.
Right, because pinpointing every single point in a 3D scene.
It would be a computational nightmare.
So how did they solve that?
Well, they got clever, divided each video frame into smaller chunks or patches.
Right.
Instead of encoding the position of every single point, they focused on the average 3D coordinates for each patch.
So simplifying the representation without losing too much accuracy.
Exactly. Makes the computation way more manageable.
Smart.
And they tested different ways to calculate those average coordinates.
Oh, interesting.
Turns out, just averaging the 3D positions of all the points within a patch, that worked best.
Huh. You'd think something more complex would be needed.
Right. But simple averaging, it strikes that balance.
Between.
Accuracy and computational efficiency.
Gives the AI enough information to understand the scene.
Without drowning it in data.
Makes sense.
And speaking of balance, the paper also talks about how they fine-tuned the model
Oh.
to make sure it didn't rely too much on either the visual information or the 3D positional data.
Right. So it's not biased towards one or the other.
During training, they experimented with different combinations. They found that balance was key for overall performance.
So it's like finding the perfect recipe.
You got it. Too much reliance on visual features, and the model might struggle with new scenes,
Makes sense.
but lean too heavily on the 3D data, and it might miss those subtle visual cues.
It's like trying to understand a city with just a map versus just photographs.
You need both to get the full picture.
This model needs both to truly understand the 3D scene.
Exactly. And the researchers, they were meticulous about finding that balance.
And it paid off.
The results speak for themselves.
So they put this model through its paces.
Oh, absolutely. Rigorous testing.
Using those standard benchmarks for 3D scene understanding.
Each one designed to test a different aspect of the model's abilities.
Like what? Give me some examples.
Well, there was 3D object retrieval.
Right.
Give the model a description, like find the red toy truck on the floor.
And then it has to actually locate it.
In the 3D scene, based on the description alone,
Sounds tough.
it's like 3D hide and seek, and the model excelled.
Impressive.
Then there's 3D visual question answering
Okay.
open-ended questions about the scene, like what color is the chair next to the window?
So not just recognizing, but understanding.
It's like going from recognizing words in a book to understanding the story.
I like that analogy.
They also tested 3D captioning.
Where the model has to describe the scene.
Capture the objects, their attributes, spatial relationships, the whole picture.
Painting a picture with words.
And across all these benchmarks, Video 3D LLM consistently outperformed existing models.
Really? That's amazing.
The power of this new approach is clear.
So beyond these tests, where could this be used in the real world?
Oh, the possibilities are huge. Robotics, for one.
In what way?
Robots could navigate complex environments with a whole new level of understanding.
Not just avoiding obstacles, but really getting the layout.
The relationships between objects interacting more intelligently.
It's like robots going from simple machines to something more, well, intelligent.
Precisely. And think about virtual reality, augmented reality.
Oh, right.
Imagine stepping into a virtual world that's not just visually amazing, but spatially coherent.
You could move around, interact, truly immersive.
Revolutionize gaming, education, even remote communication.
And self-driving cars.
Absolutely. Imagine cars that understand the complex interactions happening around them.
Pedestrians, other cars, everything in that dynamic 3D space.
A game changer for safety and efficiency.
And of course, the benefits for people with visual impairments.
Providing them with real-time spatial information.
So they can navigate the world more confidently.
The potential societal impact is huge.
This technology could really make a difference.
As it develops, we'll see even more applications emerge, things we can't even imagine yet.
This is just the beginning for 3D scene understanding.
A truly exciting time.
This has been fascinating, exploring Video 3D LLM and its impact.
I agree.
But there's one more thing I want to touch on, the limitations.
Right. Important to consider those.
No model is perfect.
Understanding the limitations is key for responsible development.
We're back, and we've been really getting into the nitty-gritty of Video 3D LLM.
This model that's really pushing the boundaries of 3D scene understanding in AI.
But like we said before, no model is perfect. There are always limitations.
Absolutely. Understanding those limitations is crucial.
So let's dive into that. What are some of the challenges facing this technology?
Well, one thing that jumps out is the reliance on massive amounts of training data.
Yeah, we touched on that earlier.
Even though it's more efficient than some others, it still needs a lot of data to learn.
And getting all that data, especially video data.
Organizing it, labeling it,
It's a huge undertaking.
time-consuming,
It's
expensive.
definitely a challenge.
So Finding ways to reduce that data dependency, that's a big focus for research.
Makes sense.
Another challenge is handling, well, the unusual
You mean like?
objects or scenes the model's never encountered before.
Right, because it can only learn from what it's seen, right?
Exactly. So what happens when it comes across a new type of furniture or a weird architectural design?
Yeah, something totally out of left field.
Generalizing to new situations, that's always tough for AI.
So how are they addressing that?
Researchers are working on ways to improve that adaptability, but it's an ongoing thing.
And something else I noticed, the paper mostly focused on indoor scenes. That's true. I wonder how this model would handle the complexity of outdoor environments.
It's a good question. Indoor scenes are pretty controlled.
Right, the real world is much more chaotic.
Varying light, weather changes, things moving around like cars and people,
That's a whole other level.
like the difference between a video game and real life.
Exactly.
And the researchers, they acknowledge that. They say future work needs to address those complexities.
So while this research is exciting, it's clear there's more to do.
Absolutely. But the progress is undeniable.
It's laying the groundwork for the future of 3D scene understanding.
And as the technology keeps developing, we'll see even more incredible applications.
Well, this has been an amazing deep dive into Video 3D LLM.
It really has.
It's shown us the incredible potential of AI, how it's evolving to understand the world around us.
And to our listeners, thanks for joining us on this exploration.
We hope you found it as fascinating as we did.
And as always, remember to check out the show notes
For links to the research paper and other resources.
if you want to delve deeper into this topic.
Until next time, keep exploring, keep learning.
And stay curious.